When people ask about backup in VM Essentials, they often expect something similar to VMware, snapshots, schedules, and a checkbox that says protected. The reality is very different. In this video, I want to step back and explain how to think about backup in VM Essentials environments, not how to implement it, but how to reason about constraints, risks, and design choices. VM Essentials is positioned as a federation layer. It allows organizations to manage VMware and KVM environments together. From a backup perspective, that's an important distinction. On the VMware side, backup follows well-established patterns, using VMware's native APIs and existing tooling. VM Essentials does not change that. The real question is not how to back up VMware. The real question is how to design backup for the KVM side, while keeping a coherent operational model across both worlds. That's where the challenge appears. On the KVM side, snapshot behavior and consistency depend heavily on the storage backend. VM Essentials brings these worlds together, but backup semantics remain different. Once you accept that, the next step is to understand the constraints that shape the KVM side. When discussing backup in VM Essentials, it's very easy to mix up concepts like agentless and snapshot-based. The reason is that these terms don't describe the same thing. They actually describe two different design dimensions. The first dimension is control plane, where the backup logic lives. That's where the distinction between agent-based and agentless comes from. The second dimension is a data plane, where data is actually captured. That's where snapshot-centric designs appear. Agentless and snapshot-centric are not opposites. An agentless backup can absolutely be snapshot-based, and many real designs combine the two. Once you separate these two dimensions, backup design becomes much easier to reason about. Because each dimension comes with its own constraints and risks, especially on the KVM side. From this point on, I'm focusing specifically on the KVM side of VM Essentials, because this is where backup constraints fundamentally change. On the VMware side, backup relies on a well-defined framework and APIs. On the KVM side of VM Essentials, there is no equivalent standardized backup API framework. That means backup semantics are not provided by the platform. They are reconstructed through orchestration. This is the first non-negotiable constraint. On the control plane side, this has important consequences. Because backup is orchestrated externally, visibility into the guest is limited, ordering becomes critical, and behavior depends heavily on platform APIs. Failures here are rarely catastrophic. They are partial or silent. A freeze is skipped, a timeout occurs, or state drifts without being immediately visible at the platform level. On the data plane side, constraints are even more structural. Snapshot-based backup functionality exists on KVM and can be implemented effectively, but remains scoped to the host and the storage context. Snapshots do not inherently understand VM mobility. They don't automatically follow a VM as it moves across hosts or environments. As a result, the control plane must remain continuously aware of VM placement and movement. Backup correctness depends on orchestration, keeping metadata, storage context, and VM lifecycle aligned at all times. Finally, restore becomes a cross-layer operation. Correct recovery depends on the alignment of control plane state, hypervisor state, storage snapshots, and VM metadata. A snapshot can be fast and technically successful, yet still be insufficient for a reliable restore. These are not implementation issues. They are structural constraints of VM Essentials on the KVM side and of the design choices required to operate at this level of abstraction. So far, we've talked about platform constraints on the KVM side of VM Essentials. What matters next is how those same constraints surface in day-to-day operations, depending on the backup pattern you choose. Let's start with agent-centric backup, where logic runs inside the virtual machine. In this model, application consistency is strong and restore behavior is usually predictable. But that consistency comes at a cost. Backup agents have their own life cycle, and operational overhead increases as environments scale and VMs move. With agentless orchestration, which is common in VM Essentials environments, control is centralized at the platform level. Backups often report success, schedules run as expected, and operations look clean. However, platform-level success does not necessarily imply restore certainty. Because backup semantics are reconstructed by orchestration, timing and VM movement matter, and state can drift across orchestration layers over time. Snapshot-centric approaches focus on storage primitives. They offer very fast capture windows and minimal impact on running workloads. But when backups are coordinated at scale, snapshot storms can appear, and restore behavior becomes highly storage-specific. Cleanup and rollback are often more complex than expected. None of these patterns is inherently wrong. They all operate under the same platform constraints. What changes is how and when those constraints become visible. At this point, evaluating a backup solution is no longer about features or mechanisms. It's about understanding where responsibility lives. Some solutions place responsibility inside the virtual machine. Others place in the control plane or in the storage layer, and many split across all three. The key question is not how backup is implemented. The key question is what the solution guarantees and what it assumes. What consistency is actually guaranteed? What consistency is merely assumed? And who detects when those assumptions no longer hold? Finally, you have to look at behavior under stress. When something goes wrong, what fails first? What degrades gracefully? And what becomes manual during an incident? Good backup solutions don't eliminate constraints. They make responsibility and assumptions explicit, so those constraints can be managed. If a solution cannot answer these questions clearly, it's not ready for production. Throughout this video, the goal was not to explain how to configure backup in VM Essentials. It was to explain how to think about it. When VM Essentials spans VMware and KVM, backup stops being a feature and becomes an architectural problem. Different backup patterns, agent-centric, agentless, snapshot-based, are all valid. What changes is where responsibility lives, which assumptions are made, and how risk surfaces in production. On the KVM side, the absence of a unified backup contract, host scope primitives, and orchestration-driven semantics introduce constraints that cannot be designed away. Those constraints don't mean backup is impossible. They mean that operational behavior becomes predictable once you know what to look for. Good backup design isn't about certainty. It's about understanding what you're trusting and why. This was the mental model. Next, we'll look at how it breaks and how to design around that. In upcoming videos, I'll go deeper into specific constraints, real-world failure modes, and how to reason about backup designs in practice. Thanks for watching.